So today's notes are called the law of sines. Law of sines. We're not going to write the target for today. The target is students will be able to derive the law of sines by drawing an altitude of a triangle and using the sine function to find two expressions for the length of the altitude and simplify the equation that results. Students will use the law of sines to solve problems. That was a long target. That's what we're going to be able to do. All right, so what we've been doing is we've been solving right triangles correctly. I mean, correct? Hopefully we've been doing them correctly, right? All right. So not every triangle is a right triangle. Am I right? Yeah, you're right, Miss Riley. So today we're going to figure out what to do, how to solve when we don't have our right triangle. Do y'all remember what an oblique triangle is? What? No sides are equal. And what about your angles? They're also not equal, and they have three acute angles. Y'all remember what an acute means? What? Less than 90. So an oblique triangle is a triangle, obviously, that does not contain a right angle. If it did, it would be called a right triangle. An oblique triangle has three acute angles. And remember, acute means less than 90 degrees. What's that? Three acute angles. Or it can have two acute angles and one obtuse angle. Remember what obtuse means? Greater than 90 degrees. So you can have one that looks like this. All of those angles are less than 90 degrees. So this would be a triangle, an obtuse triangle with three acute angles. Or you could have one that looks like this. Again, no 90-degree angles, but one of your angles is obtuse. Now, trig functions, we use trig functions on right triangles, like sine, cosine, and tangent. We use those on right triangles. So we can't use trig functions to solve a triangle that's not a right triangle, okay? We can't use trig functions on these triangles because there isn't a 90-degree angle. Therefore, we will develop new relationships in order to work with oblique triangles. One such relationship that exists among the sides and angles of a triangle I'm going to say of an oblique triangle, so I'm going to put oblique in parentheses, is called the law of sines. The law of sines. Anybody still writing that? Okay. All right, so let's talk about the law of sines. If A, B, and C, make sure those are all capital, A, B, and C are the excuse me, are the measures of the angles of a triangle, and A, B, and C, and these are all lowercase, are the lengths of the sides opposite these angles, then dot, dot, dot. A divided by sine of A, so that's a lowercase a divided by sine at an uppercase A equals lowercase b divided by sine at uppercase b equals lowercase c divided by sine at uppercase c. So the lowercase are the legs across from their respective angles. The uppercase is the sine at that particular angle. Also need to note the ratio of the length of the side of any triangle to the sine of the angle, S-I-N-E sine, opposite that side is the same for all three sides of the triangle. So part of the target for this lesson is we have to prove the law of sines. We have to prove how they came up with this, prove that it's true, okay? So that's what I'm gonna do next. Everybody caught up? I'm just gonna move it up a little. All right, to prove the law of sines. Sorry, we have a lot of like writing to do today. Y'all know that happens sometimes. We draw an altitude of length h from one of the vertices of the triangle. What do I mean when I say vertices? Just the vertex, right? It's plural for vertex. So I'm just going to draw an obtuse triangle here. And I'm just going to draw an altitude from angle C down to the leg opposite of that angle to form a right triangle. And it said we draw an altitude of length h. So that becomes the altitude of the triangle, right? You got to go back to your geometry. That's the altitude, the height of the triangle. And I'm going to label that point D. Okay. So when I'm talking about C is the length of AB. That's what your C is. I'm going to rewrite it like this. That is your C, the length of AB. So I formed another triangle, right? I've got AD. I have the length of AD and the length of BB. C is the length of AB. So did we not just form two smaller triangles that are both right triangles, right? Okay. So when we draw in the altitude, two smaller triangles are formed. We have triangle ACD and triangle BCD. And they are both right triangles. This will help us because we can use the definition of the sine of an angle of a right triangle. All right, so we know that sine at theta is equal to opposite over hypotenuse, correct? Okay. So let's start with, let's look at the sine of angle B. Sine at angle B equals, what leg is opposite angle B? Well, I'm sorry, we're looking at the smaller triangles. We labeled it H, right? D is the angle that it forms on the, okay. So the leg opposite of B of the smaller triangles is angle or a side H. And what is the hypotenuse of triangle BCD? Lowercase a. All right. Well, what I'm going to do now, because I'm trying to prove this, I'm going to isolate the H. I want to get H by itself. So if I want to do that, what could I do first? Multiply everything by A. So that gives me A times the sine at B equals H, right? Or we could say H equals A times the sine at B. Well, let's do the same thing, but let's find the sine at angle A. The sine at angle A equals, so we're looking at triangle ACD now, just a smaller triangle. So in triangle ACD, what is the leg opposite of angle A? H. And what's the hypotenuse of triangle ACD? Lowercase b. Again, we are going to isolate the H. So what do? Multiply both sides by B. So we have B times the sine at A equals H. Or if I want my H on the left side, H equals B times the sine at A. And I wish I would have used the whole piece of paper for this because I'm going to have to go to the next page to continue this, and I don't want to do that, but I'm out of room personally. So what I'm going to say on the next page is, because we have found two expressions for H, over here we have H equals A times the sine of B. Over here we have H equals B times the sine at A. So we have two things that are set that H equal, okay? So we're going to take, if H is equal to A times the sine at B, H is equal to B times the sine at A, we're going to take what H's are equal to and set those equal to each other. And I'm going to do that on the next page. So because we have found two expressions for H, we can set these expressions equal to each other. So we have lowercase a times the sine at uppercase B equal to lowercase b times the sine at A. So I'm going to divide both sides. As long as I divide both sides by the same thing, that's okay, right? No matter what I divide by, it's okay as long as I do it to both sides. So I'm going to divide both sides by sine at A times sine at B. Sine at A times sine at B. As long as I do that to both sides, then I'm good. Well, on the left side, it's A times the sine at B. So that's like two factors. Sine at A times sine at B. So that's like, it's a product. When you have a product, you can cancel out just pieces, right? So on the left, doesn't sine at B and sine at B cancel each other out? Okay, and what cancels on the right? Sine at A, good. So on the left, we're left with lowercase a divided by the sine at uppercase a equals to, on the right, lowercase b divided by the sine at uppercase b. Well, our law of sines was lowercase a divided by sine at a equals b divided by sine of b equals c divided by sine at c. Didn't we just prove part of the law of sines? Yes, so that was our goal. We haven't proved the whole thing, but we just proved part of the law of sines. This proves part of the law of sines. If we use the same process, and draw an altitude of length h from vertex A, we obtain the following result. So last time we drew the altitude from angle C to side C, okay? So if we did the same triangle, but we drew an altitude from angle A to side A and did that same process all over again, then we would come up with B divided by sine at B equals C divided by sine at C, which is the other part of the law of sines. So when we combine this equation with the previous equation, we obtain the law of sines. All right, so are y'all ready to actually use the law of sines now that we know how it's derived? I'm sure y'all are like, I don't care how it's derived, just show me how to use it, right? But we had to show you how. Everybody cool so far? All right, a little more writing, and then we'll actually do some work. So the law of sines can be used to solve a triangle in which one side and two angles are known. The three known measurements can be abbreviated using SAA. Don't remember what that means? SAA? Side angle, angle, good. If you liked geometry, then you probably like the next couple of lessons. Or a SA, which means what? Angle, side, angle. That means the side is included between two angles. Side angle, angle, the side is not included in between the two known angles. All right, so let's do an example. Example 1, we're finally to an example. And I don't think we're going to finish all these notes today. So let me draw a triangle. It's going to be obtuse. Angle A is given to me and it's 46 degrees. Side A is given to me and it's 45.2. Angle B is given to me and it is 71 degrees. And that's all I know. I don't know angle C. I don't know side B. And I'm putting like circles and boxes. So that way, when I look back at my notes, I know what the missing information that we found. All right, so at this point, is it pretty easy to figure out what angle C is? Yeah, we know to find angle C, we would do 180 degrees, because isn't that what you get when you add all three angles of a triangle together? Minus the other two angles, so minus 46 degrees, minus 71 degrees, and that should give us 63 degrees. So we know angle C is 63 degrees. So we know that. So now we need to find the other two sides. We know, well, now we know three angles, but before we knew angle, angle, side, right? Before we knew that angle. Or now we know angle, side, angle as well, but either way. So we want to start with a ratio in which we know both parts, meaning the angle and the opposite side are known. All right, probably should have done this one on a separate sheet of paper as well, but I didn't. So I'm going to write that over on the side so I have a little bit more room. Start with the ratio in which an angle and its opposite side are known. So like the only side that I know is side A, right? So we have to at least start with A over sine at A, because we know that angle and the side opposite. On the other ones, we know the angles, but we don't know the sides opposite, okay? So we know A over sine at A, and we're gonna set that equal to either B over sine at B or C over sine at C. It doesn't matter because we need to find everything, okay? It doesn't matter. So I'm just gonna start with C over sine at C. So I know all of these parts except for side C, correct? Okay, so A is referring to the leg, so that's 45.2 over the sine at 46 degrees. Because that's angle A, equals, I don't know side C, so I'm just going to put a C there, over the sine of C, so that's the sine at 63 degrees. Now I am trying to solve for C, correct? C is being divided by the sine at 63 degrees. So what do? If I want to get rid of that sine of 63, multiply both sides by what? Sine at 63 degrees. So on the right side, the sine at 63 degrees cancels, and I'm left with C. On the left side, I have sine at 63 degrees times 45.2 divided by the sine at 46 degrees. We're going to have to put that in our calculator. And you want to be very careful. If I were you, would not try to enter it all at once. I would simplify the top, get a number, then divide by sine at 46 degrees. So you put it in your calculator, see what you get. I'm going to put it in my calculator, see what I get. What y'all get? 56 if you round. So what everybody got? That's what I got too. 56. So I did my numerator, I did sine at 63 degrees. So 63 sine times 45.2 and equals. So that's the top simplified. Divided by 46 sine, and then you have to put, because that is just the sine of 46 degrees, okay? And then you have to push equal sign to get 56. Coolio. So C is 56. That wasn't too bad, was it? It was not so bad. All right, now we need to find B. Hopefully my green shows up. So now I know angle A and its leg opposite. I know angle C and its leg opposite. So I could use either one of those, A over sine at A or C over sine at C. Whichever one I use, I got to set it equal to B over sine at B because that's what I need to find, right? So I did B over sine of B equal to A over sine at A. I don't know if this green was my best choice. Can y'all see that green okay? All right, I'm stuck down in the corner. Okay, so I don't know B. And I'm looking for the denominator sine at 71 degrees equals A is 45.2 over the sine at 46 degrees. I want to get B by itself, and B is being divided by the sine at 71 degrees. So what would I do? Multiply by the sine at 71. So I'm cramming this in here. So on the left side, everything cancels except for B. And it doesn't matter. I set that up with the unknown part on the left, and last time I set the unknown part on the right. It doesn't matter. It's one's equal to the other, so it doesn't matter. And then put that work in your calculator and see what you get. If you round to the nearest tenth place, what'd y'all get? 59.4, that's what I got. On the last one, I rounded to the nearest tenth place, it just popped it up to 56. But on this one, the nearest tenth place, it's 59.4. Have I found every angle and every leg of my triangle? Heck yeah. Anybody have any questions? All right, I bet we can get another one in. So that was a angle side. That was an angle side triangle. That's what we were given. 2 angles and a side, and the side was not included. Look at example 2. What happened to my camera? Give myself a little bit more room this time. So on this one, I'm given angle A is 64 degrees. I'm given angle C is 82 degrees. I am not given angle B. I gotta find that. I'm given side C is 14 centimeters. I don't know side A, and I don't know side B. So that homework yesterday, I wanted you to draw the triangles out and label the triangles, so it didn't take me 25.5 years to grade each paper. When we were doing these, same thing. I want you to show me your work, how you found it, but label it on the triangle, so it doesn't take me so long to grade. All right, is this an angle side angle or an angle side? Angle side, because the side is not included in between the 2 angles that we know, right? So this is an angle side, or you can say side angle, it doesn't matter. Same thing. 2 A's and S. The S is not between the A's. All right, so we're gonna solve the triangle. When you have to solve the triangle, that means find every angle, find every side. So what leg and angle do I know that are across from each other? C. So I know I'm going to have to start with C over sine at C equals. And I can either do B over sine at B. Well, right now I can't because I don't know angle B or side B, but we can figure out that angle, right? Or we can do A over sine at A because we know one of those. Let's just go ahead and do A over sine at A. So to do this, you have to start knowing an angle and a leg across from it to be able to use law of sines. All right, so C is 14 over sine at 82 degrees equals, we don't know leg A, that's what we're trying to find, over the sine at 64 degrees. So what are we going to do? Multiply by sine at 64 degrees on both sides. Remember, that's in the numerator. So y'all put that in your calculator. At home, y'all should be putting that in your calculator too, to make sure you're getting the same thing we are. You know how to enter it into your calculator. All right, rounding to the nearest 10th place. What did y'all get for A? 12.7, that's what I got too. And that's centimeters, right? They told us this is in centimeters. All right, so to find angle B and side B, we can't find side B until we find angle B. So that's easy. We know angle B is 180 degrees minus 82 degrees minus 64 degrees, and that should be 34 degrees. So now we can find side B. So I can either use A over sine at A or C over sine at C. It does not matter because I know both of those, but I have to use B over sine at B because that's what I'm trying to find, right? So I'm trying to find B over sine at B. So since I know the other two, it doesn't matter which one I use. I just use C over sine at C. It doesn't matter that I used it in the last one. It doesn't matter. So I don't know B. So B divided by the sine at 34 degrees equals 14 divided by the sine at 82 degrees. So we want to solve for B. So what are we going to do? Multiply by the sine at 34 degrees. Good. So y'all do that in your calculator. And what do you get rounded to the nearest 10th place? 7.9. Coolio? All right, so the bell's going to ring any minute now. We are not finished with these notes. We will do another video on Monday to finish it up. All right, and I'll post this on Schoology as soon as it's ready. And everybody at home, we'll see you on Monday. Don't forget Tuesday if you are taking the ACT to be at school at 7. I think that's just Yasmin and Carmen from everybody at home.
Miss Rayleigh, hope you have a good day.
Thank you. Y'all too. See you Monday.